Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of physics, which is electricity, focusing on Ohm's law and circuits. This topic is crucial for NEET aspirants, as it forms the foundation for understanding electric circuits, resistance, and voltage distribution. A clear understanding of these concepts will help you solve complex circuit-related problems with ease. Electric current is the flow of electric charge in a conductor. It is defined as the amount of charge passing through a cross-section of a conductor per unit time. Mathematically, I is equal to Qt, where I is the electric current, measured in amperes, A. Q is the charge, measured in coulombs, C. T is the time in seconds, S. Electric current is caused by the movement of free electrons in a conductor under the influence of an electric field. The direction of conventional current is taken as the direction of flow of positive charge, opposite to the actual movement of electrons. Now, let's discuss Ohm's law, one of the fundamental principles governing electric circuits. Ohm's law states that the current flowing through a conductor is directly proportional to the voltage applied across it and inversely proportional to its resistance. Mathematically, V is equal to IR, where V is the voltage or potential difference, measured in volts, V. I is the current, measured in amperes, A. R is the resistance, measured in ohms, omega. From this equation, we can see that if voltage increases, current increases, provided resistance remains constant. If resistance increases, current decreases for the same applied voltage. Resistance is a property of a material that opposes the flow of electric current. The resistance of a conductor depends on length, L, of the conductor. Resistance is directly proportional to length, RL. Cross-sectional area, A. Resistance is inversely proportional to area, R1/A. Resistivity, ρ, a material-specific property that affects resistance. The relation between these factors is given by R is equal to ρ, LA, where ρ is the resistivity of the material. Different materials have different resistivity values. Conductors like copper and silver have low resistivity, while insulators like rubber and glass have high resistivity. Now, let's discuss electric circuits and how resistors can be connected in different configurations, series and parallel. In a series circuit, resistors are connected end-to-end, and the same current flows through each resistor. The total resistance in a series circuit is the sum of individual resistances. R_Req is equal to R+R+R+. The voltage is divided among the resistors, but the current remains the same throughout the circuit. In a parallel circuit, resistors are connected in such a way that they share the same voltage but allow different currents to flow. The total resistance in a parallel circuit is given by 1R_Req is equal to 1R plus 1R plus 1R plus. This means that the equivalent resistance in a parallel circuit is always less than the smallest individual resistance. One of the most important applications of Ohm's law is in Kirchhoff's laws, which help in analyzing complex circuits. There are two key laws. Kirchhoff's current law, KCL, states that the total current entering a junction is equal to the total current leaving the junction. This is based on the conservation of charge. Kirchhoff's voltage law, KVL, states that the sum of all voltage drops in a closed loop is equal to the total applied voltage. This is based on the conservation of energy. Understanding these laws is crucial for solving circuit problems, especially when multiple resistors, voltage sources, and branches are involved. Resistance is the opposition that a material offers to the flow of current. It depends on the length, cross-sectional area, and resistivity of the material. The resistivity of a material is an intrinsic property that determines how strongly a material opposes current flow. It is given by R is equal to ρLA, where ρ is resistivity, L is the length of the conductor, and A is its cross-sectional area. The concept of resistors in series and parallel combinations is crucial in circuit analysis. In a series circuit, resistors are connected end-to-end, and the total resistance is simply the sum of individual resistances. R_total is equal to R1 plus R2 plus R3 and so on. The current remains the same throughout a series circuit, but the voltage is divided among the components. In a parallel circuit, resistors are connected across the same two points, and the reciprocal of the total resistance is given by 1R_total is equal to 1R1 plus 1R2 plus 1R3, and so on. In this case, the voltage remains the same across all resistors, but the current is divided among them. Parallel circuits are commonly used in household wiring because they allow independent operation of different devices. To solve circuit problems efficiently, it is essential to follow a systematic approach. First, identify the given values and the unknown quantity to be determined. Then, apply Ohm's law and Kirchhoff's rules where necessary. For circuits with multiple resistors, determine whether they are in series or parallel, and simplify the circuit step by step. Finally, use appropriate equations to calculate the required values. Understanding the behavior of electrical circuits through Ohm's law and Kirchhoff's rules forms the foundation for more advanced topics in electromagnetism and electronics. Mastering these concepts not only aids in solving theoretical problems but also in real-world applications such as electrical engineering and medical equipment design. For NEET, solving numerical problems on Ohm's law, resistance combinations, and Kirchhoff's laws is essential. These concepts frequently appear in exams, and practicing them thoroughly will give you an edge in problem solving. Thank you. That's all for today's session on current electricity, Ohm's law, and circuits. If you found this explanation helpful, make sure to subscribe to AskPrep for more in-depth NEET physics content. Keep practicing, and see you in the next video.